All right, here are solutions for perfect problem 7 for math 65. We're given a polynomial x to the 6th minus 64 and asked to factor it a few different ways. What we'll end up using is a few different formulas. We got our difference of squares formula, and what that says, I mean, if you're a formulaic kind of person, it says when you have something squared minus something else squared, you can factor it. And the way it will factor is like this. There's also a difference of cubes, very similar to difference of squares. Instead of a difference, meaning minus of squares, both perfect squares, we'll have a difference of cubes. And when you see something like that, it also factors according to a formula. Its formula is a little bit more complicated. Looks like this. And then finally a third one, sum of cubes. So just like we do above, we have cubes here, a cubed and b cubed. But instead of being a difference, subtracting them, we're going to add them. We're going to get a sum. When you have something that looks like that, it factors. And the way it factors is similar to what we have up here. Just a couple differences in terms of what the signs are, negatives and positives. So with these three formulae, we can factor this polynomial. So in part 1, it says factor x to the 6th minus 64 as a difference of squares. So for that, the way you do it is you recognize, oh, x to the 6th is a perfect square. It's x cubed times x cubed. And 64 is also a perfect square. It's 8 times 8. So really, my a is x cubed and my b is 8. So this thing is going to factor into a plus b times a minus b. And we get to here. But then we're not done. It says then recognize that the result contains both a difference of cubes and a sum of cubes. Look, it does. These are both perfect cubes. 8 is 2 cubed. Here's a sum of them. Here's a difference of them. So I can apply these formulas. My sum of cubes, this one, factors to x plus 2. I'm following, let's see, this formula down here. X squared minus 2x plus 4. So that's this turned into this. And this one, x cubed minus 8, factors into x minus 2 times x squared plus 2x plus 4. So what we have done is taken this polynomial and factored it all the way down to here. What we're going to do next is very similar. We're going to factor this polynomial x to the 6th minus 64. Except in part 2, instead of recognizing a difference of squares first, we're going to recognize a difference of cubes. This x to the 6th minus 64 is both a difference of squares, as we saw up here, because 64 is 8 squared, and x to the 6th is x to the 3rd squared. It's also a difference of cubes. X to the 6th is x to the 2nd cubed, and 64 is 4 cubed. So what I can do is I can apply this formula. My a is x squared, and my b is 4, and get to this. So what I've done down here is I factored this same polynomial, but I did it in a different method. Right up here I noticed I had a difference of squares, down here a difference of cubes. And much like up here, I'm not done at this stage. I think it even tells you what to do. The result contains a difference of squares. Oh yeah, it does. X squared minus 4. Right? X squared is a perfect square. It's x squared. 4 is a perfect square. It's 2 squared. So I can factor that into x plus 2 and x minus 2. And then leave this guy alone, x to the 4th plus 4x plus 16. In 3, so that's the end of part 2. In part 3, what you're asked to do is kind of take a step back and be like, wait a minute, this was the same question and I got 2 different answers. That's odd. Well, actually, you didn't get 2 different answers. Later on, we'll figure out a way to factor this thing, and maybe you would guess that your answer will be this guy times this guy. You'd be right. For For now, we don't know how to do that. So all we can do is be like, well, let's see, I got an x plus 2 here and an x plus 2 here, an x minus 2 here and an x minus 2 here. But it's these two trinomials in 1 and this one trinomial in 2. And to make sure I didn't do anything right, I'd like to show that this times this really is this to make sure my answers are the same. So that's what they're asking you to do in part 3. It says multiply x squared minus 2x plus 4, that's this guy right here, with x squared plus 2x plus 4. And that's this guy over here. And so there's a couple different ways you can multiply polynomials. The way we've been doing them is sort of this box method here. Create this grid and fill in the boxes. X squared times x squared is x to the 4th. Negative 2x times x squared is negative 2x cubed. 4 times x squared is 4x squared. X squared times positive 2x is 2x cubed. 2x times negative 2x is negative 4x squared. 2x times 4 is 8x. 4 times x squared is 4x squared. 4 times negative 2x is negative 8x, and 4 times 4 is 16. If you combine like terms, you get x to the 4th. Oh, 2x, maybe I need another color here. 2x cubed and negative 2x cubed are going to cancel each other out. And actually, negative 8x and positive 8x are also going to cancel each other out. So I got this x to the 4th. I got 4x squared minus 4x squared. Oh, those cancel. And then I got another 4x squared. So all that's left over is 4x squared and then 16. So what did I just show? I showed that this times this is x to the 4th plus 4x squared plus 16. Oh, look, that's exactly what I have over here. So in part 3, I just showed that my answers to 1 and 2 are actually the same, which is good news because if they weren't the same, there'd be something wrong with some of the work that I did. So I guess I'll call that good. That's the end of this perfect problem.